Okay, welcome to, is it technically the evening, it's like the pre-party keynote, I believe. Nothing is more fun than keeping people from a party. There's only one other time slot you want, which is the straight after lunch, darkened room scenario. That's when you know you can speak to people, when most of the audience isn't sitting there going, most. It's embarrassing when it's only two people in the audience. We're talking earlier actually about public speaking. I'm hoping that next year everyone here is considering putting in a proposal for a talk at Build Stuff. If you're not, why not? It's the best experience you can have as a speaker. And there's no difference between me here, well, other than my guitar. There's no difference between me here and you sitting there. Well, okay. Oh, right, hang on. There is a difference. You're quite right. I have a beer. I have never felt such envy from a room. Okay, so I'm going to start with a song. Don't worry, it won't last too long. And then we're going to talk about how production is not a happy place. I'm going to try to dispel some ideas you might have that production is where stuff works. It's the opposite. It's where stuff tries not to work. So to do that, though, I want to tell a little bit of a story first with a song, as you do. Oh. I want to get the sound system for my home. Okay. By the way, if you want to unnerve audio-visual people, make sure you start with a blank black background slide, because they have no idea the AV works.
Of course there is. You're still alive, she said. deserve to be? Is that the question? And it's so answers. I'm still alive. I'm still alive. I'm still alive. I'm still alive. Oh yeah, 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 yeah,
Last time I threw a pick, someone died. I'm not sure of that. We're good now. So the staff here are marvelous. All right, the moment that he said, "You're going to have to take the guitar off," I said, "Yes." It's like, I'm going to be there. I just watched him run from the back of the room all the way forward. It's fantastic. Thank you. We have it covered. Okay. So for those that don't know me, why not? I've been here for some days. You should certainly know me by now. It's very easy to locate me. There's always a bar somewhere. What a strange admittance on stage. Anyway, so this is about production and how it hates you. But before I get into it, for those that don't know me, I'll explain who I am. Now, number one, most important thing about me is I'm a dad. Number one. And yes, we are those annoying people that get into Christmas way too early. We've been shopping. This is actually about a month or two ago now. And we're already in the Christmas spirit. But as well as that, I've also written some books. I don't know. And I'm still attempting to write a book. If anyone's bought it here, thank you. I will finish it. It's only been 6 years. One of the sort of unintended side effects of writing your own book on your own time without having an editor asking you to finish it is that you get to decide when you write it. Which means that I've spent at least far too long just procrastinating on it. But that's going to be finished this year. And that's quite a commitment in November. Okay. But that's not me. That's not all I am. There's something else. I have a whole double life. What I am really is obviously a wannabe rock star. And thank you for the Build Stuff for getting that photo done of me, because I don't know what lighting technique you used, but it didn't require any filtering to make me look half normal, which is nice, frankly. Okay, but there's that, and then there's something else. I'm also a motorcyclist, and that will relate to the topic for this evening. I'm a motorcyclist, and this is my baby here. Yes, I have named her, and yes, she's a her. And I ride this thing around as much as I can. That's actually me in France earlier on this month. And the point here isn't that I ride a motorcycle necessarily. It's just the fact that I'm doing a crazy thing next year. I'm riding from San Francisco through LA, through Vegas, Salt Lake City. I believe Dallas is in there somewhere. Not what point it is, but it's in there. And then I'm going to New Orleans. I'm doing a crazy road trip all the way to Chicago. We were going to call it Route 66, but you couldn't get much further from Route 66 in some of these places. So it's not Route 66, but it is 3 weeks of me having to ride about 6 hours a day. Now, the point for everyone here is every evening, wherever I stop, I will be doing a talk. So I'll be tired, I'll be bedraggled, but I'm still going to speak on stage. So if you're in any of these vicinities, then you'll be able to get me to speak about the same topic I'm doing tonight. Also, if you happen to work anywhere near these crazy places, I'll come to your company for free. And I'll talk about the things I talk about. And that might be useful. You never know. So this is what I'm doing. This is the first. You know you've got a big journey on your hands when Google Maps will not allow you to plan it. This is the first part they would have let me plan. And then there was the second part. So, yes, this is going to be 3 weeks of my life next year. Hopefully you might tune into it on, I'm going to be streaming every night. I'll be streaming. Maybe useful, maybe not, but I'll be streaming. Okay, so does this make me utterly insane? I think it's fair to say my ex-wives would say yes. But them aside for a moment, they're not the best independent judges. Am I insane to even consider this? Yes. But that's not the point. The point is that not only am I insane, but I'm an agent of chaos. Now, this is what I'm going to talk to you about today. But I need you to take a bit of a mind switch. I need you to think slightly differently about things in order for this to make any sense at all. Because if you just think the way you have been thinking and you encounter some of these things, it doesn't make sense. It seems madness. So number one, takeaway point. We have plenty of these, so get your notepads ready. Chaos engineering. What the heck is it? Being an agent of chaos, what am I doing? It has absolutely nothing to do with chaos. Now, I honestly think if there's one thing this industry could do, it's stop naming things. We're clearly not good at this. Not only do we name things very, very poorly, but we also tend to name them according to what they're not. And if anyone here was in any way responsible for the NoSQL catastrophe, then I'd like to meet you, and I will not only take you for a beer, I will hide your body later on. So, chaos engineering itself, great phrase, sounds cool. You get to call yourself a director of chaos. Now that's a job you want. However, the term is great, the term is useful, the term is cool. Unfortunately, we've done it again. We've named something after nothing to do with what it actually does. Okay. So, as I said, I'm a motorcyclist, and my point here is that who here drives a car legally? Okay. When you're taught to drive a car, it does vary from country to country, I believe. The best story I heard was the country shall remain nameless, as will the person. They got a perfectly good license they can use anywhere in the world. They had to drive 100 meters in a straight line, and they passed. Normally, though, when you're taught to drive a car, you're told that everyone else can't see you. Assume that no one sees you, and then you'll be safer, right? You'll drive defensively. Motorcyclists do not think like that. In order to stay alive a little longer on two wheels, you're taught that not only can everyone see you, but they want you dead. It's not paranoia if it's true. And this is the way you stay alive a little longer. You assume that the road is a hostile environment that is not passive at all. It's out to get you. Which brings me around nicely to production, the story of production. You see, production also, like the road to a motorcyclist, hates you. The network hates you. The machines hate you. The users, they hate you and know where you live. See, this is actually a photo taken near where I go riding in England. This is about 5 minutes from my house. The beauty of this is what you don't see. You see this gorgeous landscape. And yes, it is England and there is sun. It was that day. So what you don't see is that there's a wonderful suicide spot just to the left here. It's called Beachy Head. People travel from all around the country to die near me. That's a challenge for your optimism. But anyway, this is when people say to me, this is what their production environment looks like, that's sort of my reaction. Well, yeah, production's where everything works. Oh, come on, really? And the best thing is I gave this talk and I gave some courses over in Florida. And all of the team there were going, in production, it works. And then the senior architect in the room, wonderful individual, gentleman called Mike, he just sat there and went, oh, no, it doesn't. And I thought, that alone is worth a talk in itself. So yeah, the truth is, it isn't a wonderful place to be. It's more like that. Most production environments I've worked in are hell. It's a place where nothing wants to work and everything's trying not to. Sorry, I'm just going to stick that over there. There we go. Otherwise it sounds dramatic when I walk. Right, takeaway point number 2. Failure is everywhere, and it's the norm. Your software, it's a minor miracle that your software runs at all. So we should be building software with the knowledge that it's kind of a miracle that it works. But we don't tend to think, because we're optimists, as developers we tend to be optimists, we probably assume different. But I want you to start thinking about failure is normal in my code. When it works, that's a time for celebration, because it's not the norm. So we should talk about some types of failure. What's out to get you? Well, the hardware, absolutely. Hardware doesn't like to work very often. When it does work, it's trying to destroy you. So that's a place for failure to happen. Functional, that's the stuff you've written that you think works. I still talk to now, when you're developing software, who here thinks they're building the right thing? I don't want hands up, because if you do, you're wrong. You're not just writing the wrong thing. You're writing entirely the wrong thing. And this is the whole point of agility. It was supposed to be about embracing change. That was it. Why? Because we should have a mantra in software development. We don't know what we're doing. They don't know what they want. And that is normal. So whenever anyone says we know, I used to work on fast jets. I used to design fast jet systems. Now you'd think if you were designing a fast jet, you knew what you wanted. A jet that's fast. But there was a lot of nuance in that. There was many ways that jet could fail. In fact, one of the jets I worked on was a wonderful jet. It managed to kill the pilots. Not in a bad way, it wasn't malicious. It was a jet that could do things that the pilot could not survive. Which seems like a design constraint to me anyway. So yeah, functional. We think we're getting the functional stuff wrong. Yeah, that's going to get wrong all the time. State transmission, the movement of knowledge and state around your system, goes wrong all the time. An HTTP request that doesn't look quite right, and we end up ignoring the wrong thing, for example. And these are the easier ones. Latency. We know about latency trying to kill our stuff. If you're working on a microservice-based system, you should be an expert in latency. If you aren't, you need to buy a book, because you will be by the time you're finished. And resource exhaustion, this is one of my favorite failures. This is the one where everyone's sitting there going, please don't take any more memory. No more objects. We don't need, oh, it's done it. And then you have the whole thing go because of it. And there are lots more. This would be an incredibly dull talk if I just rattled off every sort of failure. So I'm going to avoid that. What I'm going to do is talk about where you notice it. Because the beauty of failure is it's something you can see. It's public. Because stuff goes down. And all these stories, and I'm not pulling any of these people out going, oh, how stupid. No, what I'm saying is normality. And the one I like the best, and it has nothing to do with Microsoft. I love Microsoft. Well, that's a bit strong. They're okay. I like the fact that the statement here, Microsoft doesn't learn. I'm sure they do. But the point is, we don't learn very often. We know the system's going to fail. But when do we sit back and learn from that? It's not just Microsoft by any stretch, and that's one of my favorite tweets of all time. Particularly when S3 went down. S3 can't go down. That was the phrase. Can't possibly die. And then it did. So there's something we should learn from this. Even something we're pretty sure is going to be around forever isn't. So how do we build systems? How do we develop systems where even the most reliable assumption is wrong? Number 3. Always makes me hungry, those slides. I don't know why. Chaos engineering only does one thing. It tries to build confidence in your availability. Because one of the things we do in chaos engineering is we assume that things are going to fail. So you can't say it's going to have 100% uptime. If you go and speak to the business stakeholders and say, how reliable and available do you want the system to be? The answer will always be all the time. And then you explain in very simple terms how much money that takes. And the fact that even with that money, you can't do it. Unless you have a moon base, then you might be able to achieve 100% uptime. So you can't do it. So we have to work with these incredibly complex systems and figure out what is the availability. What does availability look like on these systems? And that's all we're doing in chaos engineering. It's what matters. It's what people see. Customers, the people that pay the bills, they are the ones that gain from this particular metric, which is why I love the discipline so much, is that for a lot of the stuff we do is hidden in the background. But chaos engineering is right in people's faces. It is the way to build systems that people rely on. There's a little story I should tell you. In the UK, when you get a new router installed, what do you think is the most, for a technically proficient person, what's the first thing someone does? Throw up. No, they ping the BBC. Now, it's an interesting prospect when you think about it. We trust that the BBC is there and working more than we do our own hardware in front of us. That's fairly amazing. Possibly a wrong assumption, but in fact, in the UK, if the BBC goes down, panic ensues. It's only happened a few times. But one of the times it happened was 9/11. So that's the level of assumption we're looking at here when a particular site has an availability problem. So it really is what matters. There are different types of availability as well, depending on how you want to measure it. You can measure it in terms of how often it's available at all. Usually uptime divided by uptime plus downtime, and you'll get a reasonable metric. You shouldn't run these things across the whole system. The whole point isn't the whole thing works. The point is that parts of it need to work at different levels. Aggregate availability is more about your requests. What's a successful request versus the total requests? Another way I like looking at that one is that the unsuccessful requests directly equate to an angry user. Makes you think differently about how your system responds. And it's all, this is a key point, it's all taken from the outside in. Everything we do in chaos engineering is thinking about how it affects the users. But working with availability is harder than it ever used to be. It's the hardest thing to do right now, in my opinion. Mainly because there's so many moving parts. If you are working on a microservice-based system, and I don't care what your definition of microservices is, I deliver a course on microservices, and the very first thing I state on that course is I don't like the term. For a start, size doesn't matter. No, I'm not going to. Being a short man, it doesn't matter. It never matters. It's not the point. The whole point of the term is we've focused on the wrong thing. If you're building a microservice-based system, though, you are building, by definition, something that is going to have interesting and compromising availability. You can't say, is the system up or down? That doesn't work anymore. It's too brutal. Up or down, it's a stupid question. You have to completely remove the assumption behind the question. Okay. There are many, many levels that can affect whether your microservice-based system is alive or not. And the one I particularly like is people. Almost all of those failures that we saw were not technical, really. They were somebody doing something under a mistaken set of assumptions. I'm hoping they were accidental. If not, then they were just very nasty people. But people are part of the challenge, or in less consultancy speak, the problem. But it's not just the people. I mean, everyone who encounters chaos engineering probably encounters it down here first. You probably looked at or bemused by Chaos Monkey. And the problem with Chaos Monkey is it's completely misunderstood. You look at Chaos Monkey and you go, it kills things. Okay. Interesting. Why? And that's the point. It's not about what it does, it's about what it leads to. And the other problem with Chaos Monkey is you immediately assume that this is the only place that these things are important. The majority of my work in chaos is at the top level, maybe at the applications level as well. I'm interested in the complicated facets of your systems, which are mostly people, and how failure results. And this is the nature of the beast. Now, this is Cynefin. If you haven't bumped into Cynefin, it's a systems theory. It's pretty good. And we think we're building software here. In fact, we put a huge amount of effort into believing we build this. We love best practices in this industry. The wonderful thing about a best practice is it's context independent. It's just do it. We like those answers. Unfortunately, unless you're writing Hello World, and if you are, I want to know how you got a job doing that. I think that's fantastic. Go home every night going, what'd you do today? Hello World. Do you know what? I've nailed it now. But that's the only software that ends up looking simple or being simple, naturally simple. It turns out you're not there. And in fact, what you do is you think you're probably there. It's complicated. It's like every relationship I've ever had. It's complicated. And in that particular environment, the best you can hope for is something being good. So someone will give you some advice and you try to apply it, and it probably might work. It's like a probability equation around good. Good says, you can probably do this. Give it a spin. Here's the rub, if you will. If you're doing microservices, particularly if you're calling them cloud native, another great term, you're probably there instead. The system is complex enough that you can't even apply good practices. They don't exist. The best you can hope for is to play with things and see what happens. We have a name for that process. It's called learning. But here is where it gets really interesting. If you're doing a very complex system made out of multiple microservices, hopefully, you're doing this because you wanted something out of the system you didn't have before. You probably wanted to embrace change a lot more. The reason that people are doing microservices, particularly when I get hold of them, is to try to make the system able to adapt, because change will happen. We don't know what we're doing, they don't know what they want. So therefore, we need to build a system that accommodates that. And here where it gets gnarly, is because you're not even in complex anymore. If you're building cloud-native microservices that evolve quickly, which was the point, then you have to throw in constant change, and you end up in the chaotic. It's okay. This was the destination we were hoping for. It's probably not what we put on the business plan, but this is where you are, where there are novel and interesting things that could occur. And you need a process, a discipline, that helps you work with these chaotic systems. And that's what we talk about in chaos engineering. This is where I think, anyway, chaos engineering gets its branding from, is because the system is naturally chaotic. And we need a process and an approach and a discipline that helps us deal with that, because we care about availability. How do we achieve availability when there is chaos? By the way, don't try and avoid chaos. The only way I can think of that you might avoid being here is by building a distributed monolith that changes all at once. In fact, a little tip for anyone who's thinking of entering into consultancy around microservices: if anyone asks you on a phone call, how do we update 40 microservices at once? The answer is, why would you want to do that? Because by definition, that very question means they have a distributed monolith. It's a giveaway. Okay. So this is Chaos Engineering 101. The beauty about this particular technique is I didn't have to write the book, therefore it's done. And it's free. You can grab this book right now. It's written by incredibly smart people that have been doing chaos engineering one way or another for some years. Worth grabbing. I will tweet the link later. So point number 4. The chaos engineering movement, this is a tweet, is as revolutionary to our industry. Yeah, the English here broke a bit, but as good as extreme programming. This is a great thing to state, and it's also, I think, quite true. We are at a point where we have a new mechanism that is as important to our discipline as something like extreme programming, which is why I love talking about it so much. But we have to frame it. It is about building confidence. The problem with most chaos engineering tools, and even some of the literature, is it emphasizes breaking things. Breaking things is a part of the method. It is not the point. For those of you that are sadistic in nature, I would like you to never do chaos engineering. In fact, I saw a wonderful discussion of what sort of person should you hire as a chaos engineer. And at the top of that spec was you have to have empathy. Because you're not trying to just break stuff. You're trying to improve the system. And improve it in a context of confidence in a rapidly evolving system. So number 5. How do you do chaos engineering? Okay. First thing you do, and this is like the barrier to entry. If you ever go to a nightclub and they say your name's not on the list, if you don't do this, if you can't achieve this, you don't do chaos. You do it only when you know what normality should look like. That's what a steady state is. What does okay look like? Now, before you rush in and go, well, everything's green, therefore it's okay, there's probably more detail to it than that. The thing about a microservice-based system in particular, or let's call it what it is, a complex distributed system, is that when you look at it, okay has many facets. It might be okay that parts of the system are dying. It might be desirable that parts of the system are being replaced. So normality takes a bit of thought. But you come up eventually, and you do this because you drive observability into the system. It's a great forcing factor, by the way. If everyone's sitting there going, so I actually had this conversation last week. Someone turned around to me and said, how do I get developers to write good logs? It's like, that's a strange question. It's very easy. You make them want the logs. We tend to be pretty good at improving the quality of what we need to make it desperately important to them. They know what their logs look like. Well, this is similar. You need to drive in observability in the system. If you don't know what normal looks like, you can't start. In fact, I'll just give you the nightmare story quickly. I was phoned up about 5 months ago, and someone said, we've done Chaos Monkey, which in itself is a strange phrase. We've done Chaos Monkey in production. It killed everything. And we knew it would. I'm sitting there going, so why'd you do it? Because you think it's about breaking that. No. If you already know that the system will be broken, don't do it. The learning is done. So you have to have a steady state and a hypothesis around it, and you believe that this is what will happen and be maintained. But you have a question. You want to know under what conditions does this hang around? If you need a pointer, sorry, I'm a big fan of old animatronic kind of movies, and that's a particularly good one. If you haven't seen it, come and see me later in the bar. I will find it on YouTube. I'm pretty sure it's there. It's a fantastic movie, and it's got lots of clay models of people walking around. And any excuse, frankly, to use the picture. But the important point here isn't about that. The important point is about the canaries. So if you're doing canary switchover in your system, right? So you're deciding that one of your microservices, you update it, you put it in production, you're ready, you've got them both there, and you do the equivalent of Indiana Jones at the beginning of the movie. Oh, it works. Right. If you're doing that, how do you make the decision that that's okay to do? If you have numbers, stats, that say when something is ready to be considered as the right option in a canary switchover, then you already have an idea what the beginnings of your stats are for steady state. You deciding that something is healthy and okay is a good starting point. So it's not as difficult as it sounds to come up with steady state. And I've switched this around a little bit. When you read Chaos Engineering book, you'll realize that this is in the wrong order. Now, the reason I drop this first, or earlier than they do in the book, is because it's so important. You don't run Chaos Monkey or chaos in production and then wonder why everything died. None of the experiments, none of the chaos engineering that I do starts with, let's destroy everything and see what happens. There's always a limited scope. I want to do this here because I can learn something. Now, it has to be a big enough scope that you're going to learn something from it. It's no good doing a piece of chaos engineering in staging and everyone goes, yeah, that's not how it works in production anyway. You're always seeking, what can we learn from this? So when you're figuring out how much of the system needs to be put under these stresses, you're trying to figure out how small can we do this and still learn something useful. So limiting chaos engineering has the best terms. Blast radius. Fantastic. Pretty sure that defines my life. Okay. Then, and this is a really important point as well, you vary real-world events. If it is very, 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 very unlikely that everything in production will die at once, your first chaos experiment shouldn't be that. Because what you're trying to do is you're trying to vary something that could actually happen. You don't just make up wonderful stories about how everything can die and go, I've had a great week. This is my job this week. I came up with this idea that there was a meteor that hit the planet, and that's the likely thing that we tested in our system. You won't learn unless you're varying something real. Also, there is a problem here. If you run a chaos experiment against your system, and the development teams look at it and go, that really can't ever happen, then immediately any learning from that is forgotten. Because you're coming up with pretense, nothing real. And this is key, yes, you should run experiments in production. Now, I should point out, most people don't start that way. You know, it's very rare when you go to a company and say, we're going to do chaos in production. Everyone good with this? That you get a good answer. You generally get, stop, what? The reason we do it in production is because that's where it happens. It's the place where learning will happen. It's the only place that we can sit back and go, that's what actually happens. You can do chaos experiments in staging, and when we do game days, I'll talk about this later on. When you do game days, you'll probably do it in staging anyway, but the learning is more limited, simply because it's more ignorable. If it's not done in production, as a phrase I use, if it happens in production, everyone can hear you scream. In staging, no one's listening. Okay, so you try and do it in production because that's where the most leverage is. And then you should automate your experiments because you don't want to be running these things yourself all the time. Simple as that. And you want them to happen all the time. And this is actually how I explain it to companies that they're going to do chaos in some sense. I say we're going to learn about the system, we're going to improve the availability, and in order to do that, we have to continuously run these things. It's no good me saying I ran an experiment today, seems to be okay, therefore we're fine. I have to run it again at another time because stuff changes all the time. So this is why automating these things is so important. So takeaway point number 6, chaos engineering affects all of these levels. You'll do it everywhere. Many of the early adopting chaos engineers I've met are fixated on infrastructure, mainly because of things like Chaos Monkey, really. They sit down here and go, well, I'm destroying virtual machines, and that seems, I like that. But what they're forgetting is that there's a whole collection of complexity above that could affect your availability in interesting ways. In fact, when I'm working with early stage adopters, one of the things I talk to them about is there anything happened in production recently where things went wrong? And when eventually they trust me enough to tell me, we sit down and go, okay, we're going to make that happen more frequently. And we're going to get a system that allows that to happen, and actually what we're doing is we're allowing the system to benefit from these problems. But they generally happen at any of those different levels. Number 7, there are some rules of Chaos Club. Number 1 rule of Chaos Club, if you're going to do it, it's about learning. It's not about hurting things at all. Hurting things or destroying parts of the system is completely subservient and supportive of whatever you want to learn. Again, I come back to, if you know your system will fail if you do something, don't do it. You want to start from a hypothesis that says, I think we'll be okay. Then you make the pain happen. So number 1, learning. Number 2, this is a big one. Chaos shouldn't be a surprise. I mean, it might be a surprise to the running system in production, but it's not a surprise to the teams. I did have a conversation recently with one particular individual who felt he was being a great chaos engineer. And his question to me was this: What happens when a team phone me up because I've destroyed their stuff? Well, what? If they're surprised by the fact you've destroyed their stuff, you're getting it wrong. The whole team, in fact, it's the team that will tell you what they want to learn about the system in the first place. So even though it might be the case that you're a chaos engineer working outside of teams, if you are, then your biggest skill will be working with them to figure out what they want to learn from their system. And it should never be a surprise. Just reiterating now, if you know what's going to happen, don't do the experiment. If you already know the system will die, don't do it. You know. Okay, some quick chaos frequently asked questions. Isn't it just testing? Isn't this just like a new brand of performance testing or something? Not really, no. It's a subtle difference. It's not really about that. Testing tends to start with the opposite of what we do in chaos engineering. Testing starts from a closed question. We want to know this happens, and we think it will. It's a very closed environment. In chaos engineering, we're doing experiments, not tests. We don't know completely what's going to happen. We hope the system's going to survive, but we don't know. If we know it will, okay, coming back to the point before, if we know it will die, then we don't do it. But we have open-ended questions. We don't know what the system will do in a given scenario, so we make that scenario happen, and then we see what happens. So it tends to be hypothesis. It's open-ended questions rather than purely verifying something. It's a subtle point, because it can sound just like verifying availability. But because there's so many complex factors, it tends to be more of an open-ended question, where you're discovering the answer. You're not just looking for confirmation. And this is how I relate it, if you want to get theoretical on this is how I relate it back. In testing, we generally do single-loop learning. We make something happen, and we verify that it happened the way we expected. Double-loop learning, though, is what you're doing in chaos engineering, where you're continually adjusting your view of what the system is all about. It challenges your basic strategic assumptions of how the system works. We're learning. So what does it look like in a company? Well, because we have to do it at all these different levels, it tends to sit, at least it seems to be the way it's emerging at the moment, is you probably have a separate security group. You may be in the security group. When you're working in security on some sort of online service, perhaps, then you're generally in a separate group whose main role in life is to surprise people by making it going, oh, no, we broke it, we got in. Now, chaos engineering looks a little similar, usually, but it's not trying to surprise you. In fact, if it was going to get boring, this is a continuous improvement group. All we're doing is trying to figure out what you want to learn about your systems so they can improve at all those levels. And this is how we work with them. We do game days. If you haven't done a game day, do one. It's fantastic fun. What you do is you set up staging, and then you destroy something. And then you watch panic ensue, because you're pretending it's production. It's a great way of exploring all of those disaster recovery plans you think you've got. In fact, if I was going to call chaos engineering a different phrase, I would say it's limited scope, continuous disaster recovery. The lovely thing about this is you probably have a disaster recovery plan. How often do you use it? Tends to be the least exercised part of your system. Could be quite expensive to do it on a grand scale. Chaos engineering is a limited version of that. We want to learn what happens when stuff happens. It turns disaster recovery being something that you do all the time. Okay. So as well as game days, which are low tech, it's just conversations, destroying parts of the system, see what happens. Lovely stuff. Then you'll come up with experiments that work at the different levels. And these are where the tooling tends to come in, where you can build your own experiments that destroy and measure what happens when that destruction occurs. Okay, I'm going to give you, before I finish up, these are my hard-earned things. These are the things you don't want to learn yourself, because they're painful. Number one, do not approach your board members and say, we are going to do chaos. I have not met a single executive that likes that idea, for good reasons. But if you say we're going to do continuous disaster recovery because we're worried about availability and it's going to be limited in scope, they like that. And then you call yourself a chaos engineer and you feel cool. So drop the term. Don't be afraid to drop the term, is the advice here. If you hear, or maybe you're thinking this yourself, well, I like the idea of chaos engineering, but we can't possibly do it here. We cannot do chaos engineering. We're a bank. Every bank I've worked with is doing chaos engineering, they're just not calling it that. And they're probably not as disciplined as they need to about doing it, and they don't do it as frequently, but they certainly do disaster recovery. So brand it that way, and you might find they're already doing it. Always, always start the conversation around a chaos experiment by how much do we need to affect? Never start from, we'll destroy everything. You come and go, well, what's the smallest thing we could do to learn something? If we've seen this happen in production, can we make this happen again without everything dying? And then we'll learn from it. We'll see that we've improved. And when it comes to growing the capability in your own companies, you'll start out by people like yourselves just doing this as part of your job. And you'll say, I'm working on the availability of my system, which is a good thing. If you say you're working on chaos, that's not usually a budgetable item in the early days. But eventually, you might have your own capability as well, which starts off as a small community of practice. People, like-minded individuals like yourselves now, hopefully, that are thinking about this and thinking that maybe we should do this because it improves things. You do these collective game days where you just get people together. You may even do this even theoretically. I've seen it done a few times now where all they're doing is people come into a room and go, what happens if US East goes down? That question alone gets a discussion happening. So a game day could be nothing more than an interesting conversation. But you do it in a collective. You get everyone involved in what-if scenarios. And eventually you'll end up with a community of interest that probably develops into your own chaos engineering group. And then you can put chaos engineer on your CV. People do. Okay. So what are the enterprise issues here? I'm assuming that most people work in some sort of enterprise, maybe work on products as well, but generally you're working in a company that thinks it's not doing software. It's lying to itself, but it thinks it's not doing software. And so in an enterprise, as opposed to someone that realizes they're doing software, what are the challenges with doing this? One of the things I've bumped into. So I always do game days early, because they're conversations. And you can make them real as well. You can apply stuff to staging. Start, though, getting people aware of the questions. Yes, I am that annoying human being that sits there and goes, what if that goes down? And everyone's happy week changes. Because they suddenly realize, well, that can't happen. Oh, hang on. It did. Actually, one of my favorite stories was working with a company in London. And they did a talk. And the talk went like this. We found a button in our software. Somebody was sitting next to me and said they found a button. And this button kills it all. And the next thing I heard was click. and the gent just turned around and said, it was the best learning curve we've ever had. It turns out it takes 45 minutes to recreate our system. We're pretty happy with that. My answer, and your answer now as a chaos engineer would be, how often do you press that button? Because maybe you should press it a few more times, because you'll learn more. Okay, has to be collaborative. You don't do chaos in isolation. You can't sit there and go, yeah, what are we going to surprise people with today? It's a collaboration. It's very much here, everyone knows the experiments that are coming. There's no benefit in surprising anyone. They can see it. And also, if you have, one of my customers I work with, there are times of the day they do not want chaos running. Now, I don't know how popular Game of Thrones is in this country. But this particular company distribute Game of Thrones. And you do not want to run chaos when the new episode has just been released. In fact, their very first question is, when are you going to do this? And you say, well, here's a schedule. And they say, well, not Monday evening, thank you. Because Game of Thrones, God's happening. Okay, so you make it collaborative. Everyone knows what's going on. Has to be scheduled. Okay, everyone knows the schedule for these things. And here's a tricky one. You have to get proper approval from product managers. And don't start the conversation with, can we break your stuff? Because they'll say no. But if you say, what's disappointed you recently in your product? What's kept you up at night because it broke? You start from there and you go, well, when can we do this? Oh, we can prove it doesn't do that anymore, continuously. And eventually you'll get someone going, yeah, okay, I approve that happening. Just not in the middle of Game of Thrones, please. You have to make everyone aware that you're running the experiments. These are not cloak and dagger exercises. You're trying to make it very obvious that you're doing these things, because that's where the learning happens. And of course, you have to share the results and what happened and the insights from it. It's no good you sitting there as a chaos engineer going, wow, we learned something about the system. Let's not tell anyone. You're always sharing the results. Okay, here's a gnarly problem, because it turns out most of the companies I work with already have tools to do chaos engineering in some respect. They're just hidden away in bash scripts. So a lot of the integration work I do is just bringing those bash scripts together and going, actually, that's kind of cool that we can do this. Back to my friend in London who found the big button in his software. We have now automated that button. And it turns out it's actually triggered by a wonderful little bash command. So it doesn't have to be dramatic, but you do have to integrate with a lot of stuff that's happening. Another big challenge for enterprises tends to be, I want to run it all on my stuff. Now, the reason this happens is because a lot of security people are interested in what you're doing with chaos. Because the downside of doing chaos engineering is you're probably leaving hooks in your software that can bring things down. Nothing frightens a security person more than... Boom, we're over. Nothing frightens a security person more than you saying, yeah, I've left a hook in there that allows things to be destroyed. You good with that? So you have to secure these things and generally end up running this stuff locally for that reason. So there's a quick introduction to what I've been working on recently in this space. And this is like a small thing. I've created a little toolkit. The aim of this toolkit is to take everything we've just discussed and make it, build a sort of open API to doing chaos. So we have a little JSON document you give to this system, which you can run locally. It's only Python. Don't damn me for that. You give it a little JSON document, and what it does is it integrates with a whole bunch of other chaos engineering systems to be able to run chaos in a consistent way. So it's a little open source side project. And the reason we're doing this is because I wanted to build something else. I noticed that these enterprise problems are real. So we've built this other tool on top that helps you do chaos in your company. Because most of the challenge of chaos engineering isn't destroying stuff at all. It's making sure that everyone knows it's happening. And make sure that everyone's aware of not only planning it, but also how you schedule it, how it gets approval. Still a big deal. You have to do that. Knowing what's happening and where it's being executed so that everyone knows. And producing results. And also giving insights. So we use this tool at the moment in a couple of banks in London where they're running chaos continuously. And the thing they love the most is the fact that they get these little insights. Now, a good friend of mine, Adrian Collier, some years ago, said, what we want to do is build a system that's like a consultant in a box. Now, speaking as a consultant, putting one of us in a box is probably a challenge. We're slippery people. But the idea was, could we somehow capture the insights, the improvements that people could make? The beauty of what we're doing with these banks is we're giving them insights. So this is like me in a box. This is the advice I would have given them if I'd seen this experiment running. And so we're trying to capture that too. And eventually we'll be capturing it across companies, and some of it you might get a suggestion, say, do this here, because we've seen this happen, and you won't even know that that's actually your lead competitor that has learned from that in the first place. Okay, and the other thing is we have to run everything on-premise, and we do a software as a service, of course. So, who's doing chaos out there? This is a small sample. And the cool thing about this slide isn't the big names. The cool thing is the small names. The cool thing is the traditional companies that you might be sitting there going, this sounds too cool for them. They wouldn't be doing this. But they do, because they recognize the learning curve to it. Okay, quick takeaways before I let you go and enjoy beer and other such frivolity at the party. First up, chaos is not just for Netflix. It did get branded out of them, but you don't have to be Netflix to do this. It's a great technique for improving and learning about your system and improving your availability. As I said, it has nothing to do with chaos. So we've named something brilliantly again. Failure is everywhere, particularly if you're building a complicated, complex, chaotic, evolving microservice-based system. You can turn it to your advantage with chaos engineering. Chaos engineering is the discipline for me that turns this nightmare of a system into something that we know how to deal with. We can work with it. It's all about availability. That's the question you start with. In terms of where it affects all these levels. And don't forget the people level. That's where it matters most. Here's the technique for doing it. These slides will be available, don't worry. They're already available online. I'll share them with you. And the point here, I guess the final point before you head off to the party. If you're doing microservices in production, it's very rare for me to be able to say, just do something. Now I can. Do chaos engineering. Get the free book. Understand the questions you can ask about availability and get stuck in today. Well, after the party. Actually, after the party is the best time to do chaos engineering. So grab the book. I have no vested interest in the book other than the fact I think you should read it. Grab it. I do have a vested interest in the open source toolkit, but grab that, have a play with it. And yeah, come and chat to me about anything to do with chaos engineering. My life stories alone are chaos engineering. So thank you very much for your time today, and see you at the party.